Alan and Albert here for another Common Core explanation of the week. We're close to finishing this up, so we're doing grade 7 today with Harry and his chicken coops. So, Farmer Harry is expanding his chicken coop. At the moment, it is in the shape of a cube with each edge measuring 4 feet long. If he decides to double the length of each edge, how many times larger will the volume of the new coop be in relation to the original? Harry, do you have something to say about your new and improved chicken coop?
Of course I do. I mean, business is booming, and we need more chickens so that we can get this business rolling.
I totally agree, and we're all for economics here at Elementary. So, the small cube here, we have a hint. It tells us each edge measures 4 feet long. And since we know this is a cube, each edge is exactly the same. So we could even insert here 4 feet, 4 feet, 4 feet. Okay, so that's the height, the width, and the depth.
It's a luxurious coop for my chickens. That's what I like.
Well, it's going to be more luxurious in just a second here.
Great.
So, we have several strategies here that we could employ. In my opinion, the easiest way would be to find out the volume of each of the cubes and then see how much larger the bigger one is compared to the smaller one. So, do you think we can find out what the actual volume of the larger cube is? What do you think, Harry?
Shouldn't be a problem.
It shouldn't be a problem. And what's our hint here?
Let's see. Each edge is measuring 4 feet, and now we're going to double the length of each edge.
We're doubling the length of each edge in the larger cube.
Gotta get bigger.
Right? So that means that each edge here is going to be 8, 8, and 8. And can you remind the audience, how do we find the volume of a cube? It's pretty simple.
If I remember, it should just be each side multiplied by each other, the cubed.
Cubed, right? We're finding each edge cubed, right? And that actually just means length times width times height. But since it's 4 for each of the edges, right? The length is 4, the width is 4, and the height is 4, we actually kind of call that 4 cubed. And what is 4 times 4 times 4?
64, baby.
64 feet cubed, right? Also known as cubic feet.
Well, I've heard that before. Now I know.
Right? So that is the smaller cube. So we can do the same operation here for the larger one. And except this time we're doing 8 times 8 times 8. And that's a bit of a tough calculation here. Do we know what 8 times 8 times 8 is? Maybe you have to use a calculator or kind of figure it out on your own. But that's actually 512 cubic feet. So now that we have each of the volumes here, how do we find out how much larger the larger cube is compared to the smaller one?
Maybe by dividing?
By dividing, right? And what are we going to divide?
Probably the cubic area of the second cube. The volume.
The volume, right, of the second cube.
And divided by the volume of the first cube.
Exactly right. So we're going to divide 512 divided by 64 to find out the actual volume, or I guess how much bigger the larger cube is compared to the smaller one. Do we have a figure for that? What are you bringing out there? Is that a calculator, Harry?
Well, you got me. I need a calculator to do these big man problems. It's just too hard to do in my head.
I totally agree. Although, we train our students sometimes to do these crazy problems in their head. But in this case, the larger cube is actually 8 times the size of the smaller cube. Does that surprise you?
Not at all.
Right? And actually, if we want a different way to figure out, just really quickly, we can see that each edge is twice as big on the larger one than the smaller one. So if this one's twice as big, this one's twice as big, and this one's twice as big, right? It's 2 times times 2 times times 2 times, which actually gets you 8 times as large.
That's brilliant.
That's not too bad. That's math for you.
Thanks.